This is an installation of cooling water pumps in front of a cooling tower basin or sump. You can see that the pumps are running smoothly and there is no abnormal sound coming out from the pumps. But you can hear some abnormal sound from this pump due to cavitation at pump suction, and the pump is pumping mixture of air and water. Let us see how this cavitation can happen due to suction puddle. Suppose this is the installation arrangement of cooling water pump in front of cooling water sump. This is cooling water pump. This is suction rubber bellow, then eccentric reducer. This is suction strainer. This is first isolation valve, and this is the suction puddle. Suction puddle is embedded inside the CW sump wall with puddle flange or puddle pipe. In this condition, minimum water level is at top of pump casing level. For flooded suction, minimum water level is top of pump casing level. This is minimum water level, and this is maximum water level. That means overflow level. In this configuration, when the suction puddle is straight, then there is a chance that squirrel vortex will be formed like this and it will come to pump suction. So pump will pump water and air. That's why noise will generate. During pump cavitation, this type of vortex will form at sump water top level, and vortex will be like this at sump inside, and vortex will enter to the pump suction like this. So option 1, first option of puddle is straight puddle. This type of straight puddle. This type of straight puddle can be used up to 6-inch or 8-inch line. But when suction line is more than 10-inch or 12-inch, then there will be chance of vortex formation. In that case, we should provide vortex breaker at the inlet of this suction puddle in this area. We can provide two types of vortex breaker. Suppose this section is like this. We can weld 50 wide by 8 mm thick plate like this horizontally. These are called horizontal vortex breaker. These plates are welded here like this. And another option is at the face, this type of cross plates are welded. This is called cross vortex breaker. So if any vortex formation is there, we can provide this type of horizontal vortex breaker of 50 wide by 8 mm thick or 10 mm thick plate like this, or this type of cross vortex breaker like this, so that this will arrest vortex formation, and these flats are welded here like this. This is option 1 puddle. You can see picture of horizontal vortex breaker and cross vortex breaker. In case of option 1 puddle, this cross-sectional area of puddle is same as suction line diameter. So in that case, entry loss will be more. In option 2, we can cut the suction puddle, straight puddle like this at 45 degree. So this portion is not there. like this. When we make this type of cut at 45 degree of suction puddle, then this area becomes about 1.5 times. So entry loss will be less and pump will suck in this direction, like this, in this direction, like this. In case of option 2 puddle, there will be less possibility of vortex formation. But still, if we see vortex is getting formed, then we can provide same manner of vortex breaker in this phase. Now, in case of option 3 puddle, this straight puddle is provided with one 45 degree downward bend like this. In this case, flow will be like this. So there will be minimum chance of vortex formation, but here the cross sectional area is same as suction line, so entry loss will be more. So we can go for another option, that is option 4, if we cut this portion like this. So this portion is cut so that this area will be little bit more, entry loss will be less, and chance of vortex formation will be further less. Now option 5, puddle arrangement. In this option, we can make puddle pipe directly downward using 90 degree elbow like this. In this case, there will be no chance of vortex formation because it will suck like this from bottom. But in option 5, since the entry area is same as suction pipe area, so entry loss will be more. That's why modified option 6 is there. In option 6, one reducer is provided here like this. This is called suction bell. This is called bell or bell mouth. If the suction size is 16 inch, then the suction bell size will be 1.5 times more. That means this reducer will be 24 inch by 16 inch. In this case, the entry area is much more and entry loss will be much less, and there will be no chance of vortex formation. But in this case, this height should be minimum d by 2. In this case, this is the d. So in this case, actually we may require more some depth like this. Some depth may be more. In this case, maybe we will have to go for more some depth to meet this d by 2 requirement. This requirement is as per Hydraulic Institute standard. Now option 7 is modified shape of option 6. In case of option 7, one strainer is mounted here. One annular ring is provided here. Another annular MS ring is provided here. And 10 mm dia MS rods are provided at about 20 mm gap like this. So this will act as strainer and vortex breaker. This will be like this. This view will be something like this. This is upper annular plate which is welded to this reducer, and this is bottom annular plate, and these are 10 mm dia MS rod welded at periphery of the annular plate at 20 mm gap. In this configuration, this strainer will act as a strainer as well as it will act as vortex breaker, so that no debris or no leaf or larger size debris will be able to go to pump suction. But in that case, more sum depth will be required to accommodate it. Height of this strainer will be about 350 millimeter. This suction puddle arrangement is the best option and it is recommended by Hydraulic Institute Standard of America. But Hydraulic Institute Standard deals with very high capacity turbine pumps like vertical turbine pump having capacity more than 50,000 meter cube per hour. But for ordinary cooling water pump where suction size is about 16 inch, 24 inch or 36 inch, we need not to go for this type of complicated puddle arrangement. We can go for puddle arrangement of any option except option 1.